Hey guys, welcome back to my YouTube channel Tech Talks with AK. In previous sections, we have covered linked list and various other operations on linked list. The next data structure that we are going to cover is the binary search tree. So what is a binary search tree and what is it useful for? A binary search tree is a collection of nodes that are connected together in a certain way. Each node in a binary search tree will have up to two child nodes, a left node and a right node, as you can see in the picture. And each node will contain some data or a value similar to our linked list. For this video series, we are going to focus solely on binary search trees that take in numbers as a value. But of course, you can make a binary search tree that holds any data type as a value if you wanted to. The way our binary search tree works is that all of the left nodes will be lesser or equal to their parent node, and all of our right nodes will be of greater value than their parents. So for example, if we start with the node 50 and we want to insert value 30, it will become left node of the child like this. If we want to insert a value of 100 now, it will become the right child of the root node. And this patterns just continues all the way down our tree. So if we wanted to insert a value of 80 now, we would say if it is greater than 50, yes, it is greater than 50. Can it become right leaf of 50? No, because 100 or 100 is already there. So now 80, what we are inserting, is greater than 100 or not? No, it's not greater than 100. Can it become left branch of 100? Yes, because there is not a child node here. Great, that's where 80 goes and we would continue. If we wanted to insert 10, it would go here. If we wanted to insert 40, it would go here. If we wanted to insert 120, it will go here. If we wanted to insert 150, it will go here. And if we wanted to insert 35, it will go here and so on. Each left node is less than or equal to its parent's node, and each right node is greater than its parent node. So we have the basic outline of our binary search tree here. But one thing we are going to change is calling all of these elements nodes. So until now, we are calling all of these elements node. But from now, instead, we are going to make each one of these elements its own binary search tree. So each of them will become binary search tree. If we think about this for a minute, it will make actually a lot of sense. Each node in our tree is basically a subtree. It itself is a root node with up to two children node, which make it is a binary search tree. So this is also a binary search tree. This is also a binary search tree. This is also a binary search tree. This is also a binary search tree, but only a parent and one child node. This is also a binary search tree, and so on. So that's how our binary search tree is going to be organized. The functionality that we want to put on our binary search tree is that we want to be able to insert value in it, which is essentially be like adding a new binary search tree to our root binary search tree. As an example, if we start with this binary search tree that has a root node of value 50 and we want to insert a value of 100 into it, so we will place a new binary search tree with no child node at the right branch. We will also have contains method on our binary search tree that will take in some value and tell us if that value is in binary search tree or not. Apart from these two methods, insert and contains, we also want a breadth first traversal method and depth first traversal method on our binary search tree, each of which are simply ways of traveling through the tree or traversing through the tree as we call it and touching every node. So the difference between these two methods, breadth first search and depth first search method, is what pattern we traverse the tree in. In depth first traversal, we will start at the top and follow each branch all the way down to its bottom, as you can see in this diagram. In breadth first traversal, we also start at the top, but we will go across each level before moving down to the next level, as you can see in this diagram. As we touch each node in tree, we will be running some function on each of them. In our case, we are going to simply log out the value of each node, but you can of course perform whatever function you want to on them. And that will be our binary search tree. Great. It might look like a lab, but we will break it down step by step and be pros at binary search tree in no time in the next videos. Before we start coding our binary search tree, we need to cover an important topic called recursion because binary search trees are very recursive structure by their nature. So, see you in the next video for recursion. That's all for this video, guys. If you like this video, please press thumbs up, share with your friends who might find it useful, and don't forget to subscribe to get notified about more technical interesting videos from Tech Talks with AK. Thank you.